Hello, my name is Mirai Agiro, and alongside me is
Nixon Munene, representing the third group of civil engineering, Group C.
Today we are going to present a report on the experiment of the shape of aggregates, that is the flakiness index and the elongation index.
Now, the experiment was carried out at the Civil Engineering Annex Lab as moderated by Mr. Juma, with the lecturer of this unit being Dr. Gadimba.
The shape test of aggregates determines the shape and size of particles. The size and shape of the aggregates directly has an impact on concrete, bond strength, workability of concrete, cement requirement, as well as the cost required for the concrete. Rounded, elongated, and flaky aggregates offer good workability, but less bond strength and mechanical strength, while the angular and irregular aggregates offer lesser workability, but good bond strength and mechanical strength. There are two terminologies related to the aggregates and its test. Number one, the flakiness index, and number two, the elongation index. Aggregates are called flaky and elongated aggregates when its length is larger than its width and its width is larger than its thickness.
Now, under the flakiness index, the flakiness index is defined as the percentage of aggregates by weight whose least dimension is less than 0.6 times the main size. The procedure to find out flakiness index is as per the international standard 2386 part 1. The apparatus used for this test is a flakiness gauge and is shown below.
Crossing over to the elongation index is defined as the percentage of aggregate by weight whose larger dimension is 1.8 times more than the mean size. This test is applicable to aggregates larger than 6.3 millimeters in size. The procedure to find out elongation index is per the international standard 2386 part 1. The apparatus used for this test is known as the elongation gauge and is shown below.
Now, onto the apparatus and equipments used to carry out this experiment, we had standard thickness gauge, a standard length, international standard sieves of sizes 63, 50, 40, 31.5, 25, 20, 16, 12.5, 10, and 6.3 millimeters. A wing balance of capacity, readable and accurate up to 1 gram is also used and is shown in the picture below. Also, the international standard sieves of sizes 63, 50, 40, 31.5, 25, 20, 16, 12.5, 10, and 6.3 millimeters are shown in the picture below.
Now, let's go through the procedure that we took. Number one, take a sample of aggregates from different points of the designated site. 2, weigh a mass of 996 grams. 3, sieve all the samples through the international standard sieves as mentioned in the table above. 4, take a minimum of 200 pieces of each fraction for testing and weigh them. 5, for flaky materials, gauge the fraction for thickness on the thickness gauge. Weigh the flaky material passing through the thickness gauge. For elongation materials, gauge the fraction for length gauge. Weigh the elongation materials retained on the length gauge.
Now, the data collected was tabulated as shown in the table below, with the summation of the weight retained obtained to be 269 grams, while the summation of the weight passing was found out to be 727 grams.
In addition to the table discussed above, nominal aperture size and thickness gauge were also tabulated, whereby the mass passing was obtained to be 1,721 grams, while the mass retained was obtained to be 174 grams. The total weight was obtained to be 1,895 grams.
Now, onto the data analysis, flakiness index was calculated using the formula summation of x divided by the summation of w times 100, where x represented the weight of the material retained through the various thickness gauges, while w represented the weight of the aggregate passing and retained on the specific sieves. Now, from our results, the flakiness index was calculated as 269 grams divided by 996 grams times 100%, giving us a flakiness index of 27%.
Coming to the elongation index data analysis, elongation index is given by mass retained divided by the total weight multiplied by 100%. In our experiment, the mass retained was 174 grams, while the total weight was 1,895 grams. Applying the formula, elongation index is given by 174 divided by 1,895 multiplied by 100%. The result was obtained to be 9.18%, which was the elongation index of the aggregates.
Now, under the recommendation, from our research, we found out that there are allowable flakiness index depending on the type of construction, as shown in the table. For example, for lower granular layer, the allowable flakiness index is 15%, while for bituminous construction, the allowable flakiness index is 25%. Now, bearing in mind that we obtained a flakiness index of 27%, we will recommend the materials to be used in bituminous construction.
A further research on the elongation index gave us two parameters, that is the bituminous concrete and 2 water-bound macadam. The maximum limit of elongation for the bituminous concrete was 25%, while that for the water-bound macadam was 15%. Based on our experiments, the elongation that we obtained can be used on both the bituminous concrete as well as the water-bound macadam.
Now, in our conclusion, we found out that the flakiness index of the sample is 27%, while the elongation index of the sample is 9.18%.
Well, that marks the end of our presentation. Thank you all.
Thank you very much.